we want to spend a little bit of time thinking about the properties of the sine and cosine functions, and in particular, the negative angle identities. So what are we trying to say here? So these are the formulas. Sine of negative theta is equal to negative sine of theta, and cosine of negative theta is equal to cosine theta. Now, if you think back to your precalculus class, you might recognize this property. Maybe you saw it written like this: negative f of x equals, f of negative x is equal to negative f of x, and f of negative x is equal to f of x. You might actually remember that these are known as odd functions, and these are known as even functions. And odd functions and even functions have certain graphical properties. So if we graph the sine function, like this, odd functions have the property that if you take the picture and you rotate it by 180 degrees, it doesn't change. And so if you think about this little loop, this negative loop right here, if you rotate it 180 degrees, that perfectly matches up with this one. Even functions have a reflection property, so that the left side and the right side look the same. So in this case, if you do a mirror image, you don't, the graph looks the same. And so these are the even and odd function properties that we have. So this is 180 degree rotation. By the way, this 180 degree rotation can also be seen as a horizontal followed by a vertical reflection. And this is reflection across y-axis. And so this is one way to think about these properties. Now, the question might come up, well, why are these the properties? Why is it that sine is an odd function and cosine is an even function? One way to really understand that is to go back to the unit circle picture. So here's a unit circle picture. If we pick an angle theta, then there's a corresponding angle negative theta that we can graph. And if we look at the symmetry of this graph, we can see that on the unit circle, if we go up by theta and down by negative theta, that these 2 points, here and here, will line up vertically. And so if this has the coordinates x comma y, then since this is a reflection across the x-axis, this has the coordinates x comma negative y. And if we think further, the definition of the cosine function is the x-coordinate. If we're on the unit circle, let's say that's the unit circle, then the cosine of negative theta is x, and the cosine of positive theta is x. And that's this formula right here. For the sine function, we're looking at the y-coordinate. Sine of theta is y, and sine of negative theta is negative y, because it's now going around the circle in the opposite direction. And so this justifies why these properties hold. In the end, this picture, if you're familiar with this picture, it's a good thing. But if you find this a little bit confusing, just think about it and just keep these things in mind. And as you continue to gain more experience and more insight and more intuition into these sine and cosine functions, this will make more and more sense.